Another example here. They want us to find g prime if g of x is the function defined as a definite integral. Without getting too far off course, there are lots of functions in, say, physics and statistics that use definite integrals in the function. So, well, calculus can sometimes seem and often legitimately be sort of an exercise for the sake of doing exercises. There is some application to this knowledge, which is kind of a refreshing change from the norm sometimes, admittedly. Anyway, back on task here. They are literally asking us to find the derivative of an antiderivative. So second fundamental theorem is going to apply here. You'll notice our lower limit is in fact a constant, so we don't even have to get too fancy with it. Again, we're just going to take the very function and just exchange out the variable for the upper limit. So instead of 2t cubed, we're going to get 2x cubed. And we're going to have to remember to chain on the derivative of the upper limit, which in this case is just 1. So our answer is simply 2x cubed. You could get the same thing by going through and doing power rule, anti-differentiating. You get 2t to the fourth over 4, plug in your x, plug in your 3, and then subtract, and then take the derivative of all that. But you'll just end up right back here at 2x cubed. Another example, piggybacking off of that, find the derivative of an antiderivative. Now in this case, we have a variable as our lower limit. But that can be dealt with still. We just got to be a little clever about it. If you think about a number line, if x is here, x plus 4 would by definition have to be to the right of it 4 units. What I'm going to do is I'm going to put some constant c that's to the left of both of them. And what that allows me to do is, this is the gap, this is the interval I'm trying to cover. I'm going to define two integrals, both of them with a lower limit of c. So the way I'm going to do that is I'm going to say, well, my first integral is going to go from c all the way to x plus 4. So it's going to cover that range. That's too much stuff. I've included this extra little interval that isn't supposed to be there. So what I'm going to do is I'm going to subtract away the integral going from c to x. And that will in turn give me the very integral or interval that I'm trying to figure out. And it'll also give me two integrals that both have a constant on the bottom, and both of these will fit in very nicely with the way second fundamental theorem is set up, which is to have a constant as your lower limit. So, let's rewrite this. I'm going to do the derivative of the function being integrated from c to x plus 4 first. That's going to become, instead of 3t plus 1, it's going to become 3 quantity upper limit is x plus 4 plus 1. The second integral is going to go from c to x, differentiating that integral is going to give me not 3t plus 1, but 3 upper limit is x plus 1. Finally, I just need to subtract the two results. So let's see, this is 3x plus 12 plus 1 minus the quantity 3x plus 1 is going to give you, let's see, there's a 3x and a negative 3x. There's a 12, a 13, minus 1 takes you back to 12 again.